This will be an install for the indoor unit. Also check out my videos for the outdoor unit, as well as the concrete pad and the summer and winter test results. I'll put a link in the description below for all the parts that I use. So in my tear out video, I talked about having to make a stand. This is that stand. Here's the stand. It's all been primered and painted. So the heat pump will kind of sit right here, and I've got this extra little ledge here just due to the fact that the way it's oriented, this side has to be a little longer so the plenum can kind of come in, and therefore the orientation required a bigger stand than the heat pump. Anyway, so I'll show you that when it's actually built. But yeah, so here's the final results. I just got to put the sheet metal in place. All these screws have been drilled and tapped so I can put screws into it, and so looks like it came out fairly decent. And here I've got little footers here so I can put in adjustable posts so I can level this thing out in case the ground isn't level. But anyway, so that's kind of the deal here. I think it came up pretty decent. I'm not a welder or a machinist or anything, but just putting some elbow grease and know-how together can get stuff done. So the way it's supposed to kind of work here is these will just get bolted down or screwed down into the chassis here, and that will create my box. And then I'll go in and use duct tape to air seal everything, and hopefully this will work like a charm. Here's my little enclosure slash standoff box, whatever you want to call it. So this side will go towards the ductwork. I'm gonna align it and then cut out a hole here so I can take my intake from the the vent, supply vent, and then bring it in, and then we'll exhaust. There's suck air through here as Mr. Cool takes it. And so anyway, that's kind of that. I get it situated and look up into that intake or outtake, or however you want to call it, the line that sucks the air out of the rooms. Some of the duct work out here. Drew a little line, so I'm going to bend this tab up. It's about a ½ inch. It's not a pretty cut, but I don't have all the exact HVAC tools, so I'm gonna MacGyver it here. So again, ½ inch. Always measure twice. Obviously, I was drinking here or something. So yeah. So once I do that, I'll cut it and then fold it over so I can use it for a screw flange. All right, make sure you get to the gloves too, because this stuff will cut you. It's fairly sharp. And there we go. Plan on having this little, if you can see there's this little lip here. Thought about cutting the side of this off and then having the lip kind of hang over into here. But this is so tightly made that I don't even think I'm going to need this piece here, and I think I can just bolt the ductwork in directly through here. I thought about I'd have to cut, some of this off to get the ductwork in, but apparently it's a pretty tight fit. Probably should have made the box a little bit bigger, but hindsight's always 20/20. Anyway, so I'm gonna take this panel off and see what I got. All right, here's the cover off. I use a pallet jack to kind of lift this on here. I use a piece of wood there. Let me balance it on here, and then kind of put the wood on the lip of the little air handle here, and then pushed it over. So that was the extent of lifting this piece. It's pretty heavy. It's probably about 150, 200 pounds. It's like on the front here. Yeah, now this is where the wiring will start. The only thing I didn't like that much is it is a little wobbly. I'm going to have to secure it here. It looks like it's a little bit off with respect to level here. And so you can see on the bottom, I could probably shim that up or put some brackets in there. This is how this works. The air handler unit will send up 24 volts into the thermostat, and when you turn the fan on by itself, it'll inside the thermostat there's some relays. You can probably see that. Here's a older thermostat here, right in the I'm trying to find it here, right there. That's probably the relay that does all the switching. So when you're turning the fan on only, it connects 24 volts that comes up here, and then connects it to the green wire which goes to the fan. So that'll let the fan run by itself without the rest of the system. When you put it into cooling mode, it then sends 24 volts through that same relay to both of these wires. So it turns your fan on, and it also turns your compressor on. And everybody's unit's a little bit different, but this will actually go to the control board and turn on the compressor outside, telling it it's in cooling mode. In my system, I had a gas system, so this red wire, when I'm in heating mode, will turn on the fan and also turn on, it'll send voltage to this through that same relay through this white wire. So that tells the control board on the furnace you're in heating mode, turn on the gas. The heat pump's a little bit different. The heat pump has to know also what modes it's in, but it shares a compressor. So the compressor in one state works as cooling, meaning it takes the heat out of the building. In the other state, it works as heating. It takes the heat out of the air and puts it into the building. So in this case, when I'm in cooling mode, the same thing works. It takes this 24 volts and connects it to both the fan and the compressor, right? But the way my thermostat's set up, it's a little bit older. It's, I don't know, 15 years old. It takes the red wire, right, that 24 volts or 26 volts, whatever it is, and then turns the fan on, as well as the heat. Well, the heat doesn't go to anything. So this doesn't have a auxiliary for a heat strip. So basically the heat now has to also turn on the compressor, which is this yellow wire. And without this jumper in here, right, the compressor would never turn on. So you have to put, at least for my thermostat, this is what it calls for. The W connects to the yellow, or the white connects to the yellow. So again, anytime you're calling for heat, this provides that 26 volts. Again, the switch turns the green wire on, and also the compressor, right? But the compressor's turned on with this white wire and this jumper. So this wire right now serves absolutely no purpose. Also, it has to know outside what direction call it the bidirectional valve or the reversing valve has to be in, either in heating or cooling mode. So in this case, I'm using the blue wire, and this will basically fit into here, right, when I get it all said and done. And that will basically say, okay, you're in heating mode, right, and turn the compressor on, and basically this tells it which way the refrigerant needs to go in the system to provide heating or cooling. So that's kind of the basic setup. Again, everybody's thermostat's a little bit different. Mine's what is it, Lux 6000 or 9000 or something like that. So basically, if you look at the control panels again, here when I turn this to on, right, it connects the red to green, but when I put it to auto, then the thermostat will control all that. And here again, I'm choosing heat or cool, so it's going to choose the, oh, what color was that wire? The yellow wire or the white wire, right? So if I'm in heat, it basically shifts over the 24 volts and turns on the compressor as well as the fan, and the opposite is true here. But the blue wire basically is a signal indicator. Which way does the heat pump have to work? Does it have to work in heating mode, or does it have to work in cooling mode? So that's, again, that's my setup. Each furnace, each thermostat works a little bit different, but you mainly have, in this case, 1, 2, 3, 4, 5 wires. You might have a 4-wire system, but again, the basic concept works the same for all thermostats with 4 or 5 wires. And I can show you the wiring diagram later as well. Okay, here you can see the old system where you had the heat and the compressor separately. It wasn't a heat pump, so the white turns the heat on, and the yellow turns the compressor on, and then the green turns the fan on. So basically, whenever you wanted heat, the white would get activated. If you want. Now here with the heat pump, you have the yellow, which is the compressor signal. It turns on the compressor during cooling, but for heating, the W originally would have turned on the furnace, but now it also has to turn on the heat pump because the compressor also gets used for heating as well. So this is a setup. So basically all the control wires, yellow to yellow, black to black, red to red, white to white, and blue to blue all land on that terminal strip. Arguably, if you don't use the heat strip, you don't even need to run the white wire, but I ran it just opening in the plenum. I've got some bunch of odd angles, but anyway, so I had to cut these angles in here, and a good bending tool will make good work of this, and make little bends here, and then switch 1, 2, 3, 4. So it goes from right to left, as well as 1, 2, 3, 4, right to left. But then, if you come down and look at the manual, or the nameplate rating here, you've got switch 1 on the left versus where it is here. Switch 1 is on the right. So I wasn't too fond of that. So here's my 4-ton configuration. Sorry for all the shaking, I'm trying to zoom in here. So 1 is in the actual up position, 2 is down, 3 and 4 are up, 1 is down, or 1 is up, 2 is down, 3 and 4. So they basically mirror each other. But yeah, they could have done a better job on up and down, because when you're in the vertical position, up should be up, but based on how the documentation is, it's not too great. Anyway. Or these could have been rotated, so I don't know. I'm guessing that the board was made first, or the manual was made first, and then the board was made second, and they didn't go back and fix that, because that's just, if you're configuring something as a user, you shouldn't have to decipher left from right and what's up and what's down. And I mean, it's not rocket science, but just the fact that it should be a lot easier than trying to, you know, look at this and try to determine, okay, what's up, what's down, what's left, what's right. Anyway, that's my major complaint on the adjustability here. But so I'm going to go into the 4/10 setting, and that'll be used for my system. But again, you can do this all from the air handler. And I'm pretty sure it sets the blower speed here, and so basically there's the input for your AC and your thermostat wire. It's hiding behind here, so you just gotta kind of pull that out and then unscrew it, and there's access to your configuration switches. Okay, so here's the line set. I wish I would have given a little bit more foam here. Kind of ran short on the other end, and that could have probably been improved, but other than that, this is kind of how the line sets wrap around. I got these little metal straps I attached, and then they kind of go up and over into the hole I drilled and back outside. I'm going to test the CFM of the system. I've removed the filter that's in here. It's basically this filter here. I'm not using that. I already got one in there that's like a MERV, I don't know, 8 or 9 here. So no need to have 2 filters. And I'm going to use the velocity meter here, anemometer, so it's set at velocity and feet per minute. So that'll determine the linear feet per minute, and then once I get the linear feet per minute, then I can figure out what the cubic feet per minute is. So that'll be the next thing here. So I got a little makeshift stand so it doesn't blow over when I start sucking air through the system. Alright, this is my anemometer, so once I shut the lid here, that should jump up to right around 590 something, and that's linear feet per minute, and to convert to cubic feet per minute, you multiply the square footage of the filter area, which mine's 16 by 25 inches, convert that to feet, that's 2.77, multiply by the 596 roughly that I'm getting for a linear feet per minute speed. That gives me a little bit over 1650 cubic feet per minute. Okay, I wanted to test how loud the system was, so I got a app and I downloaded it to my phone. That's my sound meter, and it's about 54 to 55 decibels, about a foot away from the indoor air handler. So this is the done deal. So as you can see, I've got a P-trap that I installed. It's probably one of the important parts. It prevents the air handler from back sucking air into it, so it basically lets water sit in there so it doesn't suck the air back in. So that's important. And I noticed by the little condensate black covers there that was leaking a little bit of air, so I sealed all that up and then basically wrapped up the design, so everything's kind of done here. That's the front part. Still got some wiring to route and some insulation to put in, and that's the back, and pretty much that's it. It went together smooth. As I stated previously, my dislike was the configuration settings. If you rotate the panel, you can kind of see the switches are in that orientation, but again, this should have been done better. So I'm showing the 5-ton here, which is shipped with, but this is really 4-ton. So as you see the switch settings in the left, that's what I have when I rotate the cover here on the actual switch settings for the heat pump. And again, that could have been done better, but I'm still happy with the unit. I think that could have probably done a little bit better here is it's all room for air leakage, so I'm going to seal that off with, as well as over here, seal that off with duct tape. Kind of reduce some of the air leakage. Again, on the other side too. You can see kind of right here, along here, and then in the back there. So I'll seal that off with duct tape here. Again, that's where air can leak out. So we want to keep that airtight as possible. The other thing I noticed that around the condensate openings there, those black lids, there was air kind of leaking into the unit, and so I had to seal those up, as well as the HVAC penetrations. Those did also leak air, and I just used some caulking to kind of seal that up. Not a big deal, but again, if you want the maximum efficiency, you want to make sure all your air leaks are kind of taken care of. But other than that, those are my biggest dislikes. The unit itself was great and easy to install. Okay, so there was the indoor unit install. Please look at the outdoor unit install as well as my concrete pad, and look forward to results from the winter and summer months. Please like and subscribe to my channel, and I'll see you in the next video.